Okay, so we have some short answer for organic chemistry. Make sure you have your reference tables open to table P, Q, and R, possibly periodic table, and make sure we do all kinds of reading. So here we go. Base your answer to the following question on the information below and on your knowledge of chemistry. The diagram below represents ball and stick models of two molecules. In a ball and stick model, each ball represents an atom, and the sticks between balls represent chemical bonds. So the dark circles are hydrogen and the round circles are carbons, okay? So we have two different diagrams. It says explain in terms of carbon to carbon bonds why the hydrocarbon represented in diagram B is saturated. So we're talking about this one, first of all. Not like it would make any difference. However, saturated. So saturated means all single bonds. Now, when it says in terms of, you absolutely have to include that in your answer. So I'm going to say diagram, and also don't write too much. Diagram B is saturated because all of the carbon to carbon bonds are single bonds. Done. Don't answer anymore. According to the answer key, it says there are only single carbon to carbon bonds. There are no multiple bonds. You can't add more H's because the C's. Yeah, just keep it simple. Just keep on moving. All right, here we go. Now I see the paper has it in a different order. I'm just going to go in order of this. So number 2, base your answers to the following question on the information below and your knowledge of chemistry. So we have two compounds shown below, compound A, compound B. Explain in terms of molecular structure, why are the chemical properties of compound A different than compound B? So before we answer the question, let's take a look at these compounds. So compound A doesn't look like it's anything too unique. It's an alkane, which is all single bonds, hydrocarbon. And we've got 1, 2, 3, 4, 5, 6. So this is a hexane. Over here, we have 1, 2, 3, 4, 5, 6. So it's still a hex. However, this is a functional group. This is a functional group of an organic acid, and that's on table R. So this is hexanoic acid. Methylpropute penthex. Okay. So in terms of the structure, why are they different in chemical properties? So due to the organic acid functional group in compound B, the properties are different than in A. So it talks about molecular structure. So due to the, maybe I should add the inclusion of the organic acid functional group in the structure of compound B. There you go. So make sure we're talking about the structure, how it's built, the inclusion of that. So once again, that's kind of messy. It says, due to the inclusion of organic acid functional group in the structure of compound B, the properties are different than in A. According to the answer key, it says molecule B has an organic acid functional group. A does not. A has all single bonds, and B has a double bonded oxygen atom. It does talk about, yeah, you just got to talk about how it's built. You can't, talk about how it's built. Let's go blue. Base your answer on the following question. In one industrial organic reaction, C3H6 reacts with water in the presence of a catalyst. So catalysts, since we haven't talked about kinetics just yet, are any substance that will speed up the rate of the reaction by lowering the activation energy and providing an alternate reaction pathway. That is the chemistry definition. So catalyst speeds up the rate of the reaction, doesn't add anything. Like it doesn't change products or reactants. It just speeds it up, gets you there faster. It's a shortcut. So here's our reaction represented below. Write the name for the organic reaction, the left side. Okay, so here we have the left side. And we have two products. We have this one, or sorry, the two reactants, this one and this one. So who is organic? Well, let's remember that organic is anything containing carbon, which means that this is not an organic reactant. So now we have to name that left part. So it looks like we have meth-eth-prop, 3 carbons. So prop is our prefix. That's table P. Now, double bond located here means that is ENE ending. Okay, so propene, that's table Q. Now, the location, okay, location of this, 1, 2, 3. After the second carbon, 1, 2, 3. So how about 2 propene? No, sorry. I just said it wrong. 1 propene. 1 propene. All right. And that's because if you number it from right to left, that's the lowest numbering scheme. And so this comes after that. 1 propene. All right, here we go. Crude oil, primarily a mixture of hydrocarbons, is separated into useful components in a fractionating tower. At the bottom of the tower, the crude oil is heated to about 400 degrees Celsius. The gases formed rise, and then they cool. Most of the gases condense and are collected as a liquid fraction. This is called fractional, oh my gosh, so messy, fractional distillation, which they don't necessarily talk about on the regions unless, oh wait, they're teaching you right now. So yeah, they still do. The table below shows the temperature ranges for collecting various hydrocarbon fractions. Okay, so we've got, if you've got a carbon molecule between 1 and 4 carbons in length, it's going to condense off before 40 degrees, etc., etc. And then question 4 has absolutely nothing to do with any of that. It simply says, draw a structural formula for 3-ethylhexane. Okay, well, let's switch it up. Let's go. So, parent chain, hexane, meth, eth, prop, bute, pent, hex. Okay. On the third carbon, 1, 2, 3. 1, 2, 3. Well, you know what? Since I'm drawing it, I'm in charge. So I'm going to say third from the left is the 3. And it says ethyl. So an ethyl is a 2-carbon branch. So off the third, I'm going to put an ethyl group. And remember, you can make your ethyl go up like I did. You could also have your ethyl come down like I did. And also, took away a carbon here. And also, don't forget, if you are drawing this, you could say this is 1, 2, 3, and I'm going to draw my ethyl group here or here. So again, when you are drawing, you are in charge. So since I'm drawing, I'm in charge. What the heck? And bring that card. Oh no. Oh, that's highlighter. Sorry about that. Okay, so now, of course, I've forgotten all my hydrogens, which I don't need to actually write the letter H, but I do need to write the bonds. So I believe that is my 3-ethylhexane. Let's just prove it. So my hexane is here, and off the third, I have a 2-carbon branch. So 3-ethylhexane. Let me erase that red to keep it nice and clean up for you. Okay. Didn't actually have anything to do with fractional distillation. Oh, here, finally we do. Here we go. State the temperature range for the fraction collected that contains octane molecules. Let us go to the reference table. Octane. Octane contains 8 carbons. With that knowledge, so here we go. 8 carbons would be in here. And of course I drew right over it. Here we go. So carbons that are octane is the temperature range. So 40 to 200 degrees Celsius. I don't need to be more specific because it said range. Okay, I don't need to know exact. Determine the number of carbon atoms in one molecule of alkane that has 22 hydrogen atoms in the molecule. Okay, so this is where we're going to use the homologous series table Q. So back here, it is an alkane, okay? And hydrogen atoms we know. So back here, table Q. Oh, look, it's already ready for us. We're going to have double the hydrogens plus 2. And that's how we're going to figure out how many carbons we have. So Cn, N is the number of carbon atoms. We're going to double it and add 2, and that gives us the number of hydrogens in an alkane. So if you have 22 hydrogens, take 2 away and you have 20, which means C must be 10. So I'm going to go with 10 carbon atoms. But you know what? Just for kicks, let's prove it to ourselves. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. It is correct. So if I had 10 carbons, I'm going to have 22 hydrogens in this alkane. So 10 is our answer. Okay. Base your answers to 7 and 8 on the information below and your knowledge of chemistry. So fatty acids, a class of compounds found in living things, are organic acids with long hydrocarbon chains. Linoleic acid, which is an unsaturated fatty acid, is essential for human skin flexibility and smoothness. The formula below represents a molecule of linoleic acid. So here it is. It is crazy long. Number 7, it says, circle the organic acid functional group. So to remind ourselves, organic acid functional group is right here. Functional group. So C double bonded O to an OH is the organic acid functional group. So we need to find the C double bonded O to the OH functional group. Here it is. It said circle. You know what? I'm going to follow the directions. Circle. There you go. Identify the chemical bond between the oxygen atom and the hydrogen atom in the linoleic acid molecule. So between the O and the H. So I know I just circled that, but you know what? I have it twice. So that's going to be my answer to number 7. Back up here. Here's our bond between O and H. Well, I have 2 nonmetals, so that is a covalent bond. I think that's probably your best bet. It's nice and easy and we're done. If you wanted to go further, we could say, okay, let's figure out the polarity. This is 2.2. I think oxygen is 3.2. You're going to make me look it up. Oxygen, and I have to flip my head. 3.0. 3.0. So if I find the difference, it's 0.8. That is solidly a polar covalent bond. You don't need to include polar. You could just say covalent bond. I'm looking at the answer key. It also includes sigma bond. I mean, we don't talk about that in this course. Who the heck? Base your answers. Diethyl ether is used as a laboratory and industrial solvent. The boiling point of diethyl ether at standard pressure is 34.6 degrees Celsius. The equation below represents a reaction that produces it. So we got some, looks like we got some alkenes. Over here, we got some water. Catalyst speeds up the reaction. And then we got this. We got our diethyl ether. Explain in terms of the strength of intermolecular forces why the boiling point of diethyl ether at standard pressure is lower than the boiling point of water at standard pressure. Well, let me give you some room here. The stronger intermolecular forces is going to have the higher boiling point. And if you think about it, when you are held tightly as a solid, you're not boiling. This is strong force. As you go to the liquid, they're getting weaker. And as you're a gas, they're very weak, which means you're going to easily boil. And the forces are going to be very weak. So the boiling point is going to be higher if they're stronger here, and a lower boiling point if they're weaker. So let me read the question again. Diethyl ether, boiling point. The boiling point of water is 100 degrees Celsius. They expect you to know that. This is 34.6. So this is going to boil faster. So diethyl ether boils first, and it has, therefore, weaker intermolecular forces because it boils first. Because it takes longer for water to get there, it has stronger forces. And again, it's not saying that it's ice. It's not saying it's strong forces as a solid, but I'm just saying if it takes longer to boil, it's because you have stronger forces. Because it didn't take as long to boil, it has weaker forces. And finally, state why the reactions is. Let's just say the reaction is classified as a synthesis. So in a synthesis reaction, it's some. Oh, hold on a second. Having some A plus B yields AB. So a synthesis reaction, we have one product being formed. Something like that. Yeah, that's good enough. Why is it classified as this? In a synthesis reaction, one product is formed. Two reactants come together, or many reactants come together. Okay. And actually, I don't think you guys have all of these equations. So let me just, you know what? Let me just do this and just, you don't have this at all. So it's gone. You only have this glucose one. Okay, so back to this. In industry, ethanol is primarily produced by two different reactions. One process involves the reaction of glucose, a sugar, in the presence of an enzyme that acts as a catalyst, which means it speeds up the rate of the reaction by offering an alternate reaction pathway and lowering the activation energy. It does not participate in the reaction, just simply speeds it up. The equation below is as follows. Glucose with an enzyme forming ethanol and carbon dioxide. What is the reaction? This is called the production of alcohol, so this is fermentation. Formation of alcohols. And you don't need to say any, you don't need to write a nice sentence, you're just done. Fermentation. Okay? Nice and easy. If you have any questions, please let me know. Otherwise, thanks for watching.